So, what are the dimensions of the largest isosceles triangle that can be inscribed into a circle of a radius 4? So, with these inscribed questions, I recommend putting it on a grid, a Cartesian grid, with the origin at the center of the circle. This will allow us to use the radius of the circle to solve the question. So, this is the Cartesian grid over here. Oh my god, it's a bit difficult to draw on this. So, now we know that a line to the edge of the circle, to the middle of the circle, is the radius. We are given the radius of 4. So this line here, that's at the end of the circle to the middle, the origin is 4. We will denote this point as y. We also know one more thing, that at this point right here, we can set that value to x comma y. And basically x is the distance from the y-axis to this point, and this point over here, it would be negative x comma y. But basically the distance from here to here would have the same magnitude, so I'm going to put x and x here. Now let's find a relationship to help us use optimization to solve this question. So a relationship is the area of the triangle that we know. The area of the triangle is the height and the base. Uses the base and the height. So it's basically base times height divided by 2. Now the base is this line right here, the bottom line of the triangle, and it is equal to 2x. So a equals 2x times height. The height is equal to 4 plus this y over here. So height is 4 plus y divided by 2. Let's simplify this equation. So area is equal to x times 4 plus y. Now, it's to optimize this, we need to have one variable instead of 2. To find that, let's find another relationship. Another relationship we can find is the equation of the circle. And it's good because we have a grid, and the equation of the circle on the grid is x squared plus y squared is equal to r squared, where r squared is the radius and radius is 4, so x squared plus y squared is equal to 16, and we'll isolate for y, so 16 minus x squared whole root. Now with this in mind, we'll plug in y into the equation. Area is equal to x 4 plus 16 minus x squared. Expand this first, so it would be 4x plus 16 minus x squared times x. So with that in mind, let us differentiate. So this becomes 4 plus now we set it equal to 0 to find the critical points of x. So now that we find x, we'll plug it into y, which is this value right here, to find y. And the equation for y is right here. I know x squared is equal to 12, so when y is equal to root 16 minus x squared, I can choose to 16 minus 12. It's just root of 4, which is equal to 2. So basically the base is equal to 2x, right? So base is equal to 2 times root 12. This can simplify to 2 times 4 times 3. This could simplify to 4 root 3. And the height is equal to y plus 4. Y is equal to 2. So 2 plus 4 is equal to 6. So this is basically our dimensions, and also a restriction we can make to x, which I forgot to make before, should be x belongs to 0, and for the reason because the x can equal 0, it can be touching this, or the x, or the x at greatest can equal 4, because y can also the lowest equal 0. And if you plug in y equals 0 and you solve for x, x should equal 4. That's the maximum it could reach. So this is the restrictions for x. And yeah, that's basically it. Our dimensions for the base is 4 times root 3 and then the height is 6